Hello all, welcome to the video lecture series for the subject compiler design. Now I am going to explain you about the topic called operator precedent parsing, which is the most important parsing technique in bottom-up parser. Let me tell you some importance of operator precedence. It is a kind of shift reduce parsing method. It is applied to a small classes of operator grammars. And most importantly, this grammar is said to be operator precedent grammar if it has two properties. Say for example, a given particular grammar should not have a non-terminal value which is pointing an epsilon. This is what is it like? This grammar will not have a properties of operators precedent. Okay. Second most important part here it is any given grammar you should not have the non-terminal which is adjacent. Say for example, A is a non-terminal, it is in the left hand side, and S is a non-terminal, and adjacent to that non-terminal is A here. So there should not be any grammar, given grammar, which should be in this particular scenario, right? So this grammar is said to be operator precedence if this two properties is applied, right? So I'm going to showcase now how this operator precedence is performed based on the steps. It has 5 steps to be performed. Number 1, compute leading and trailing. Number 2, compute precedence relation. Number 3, constructing the parsing table. Number 4, parsing the given input string. Number 5, precedence graph and mapping. Right. So let me take you to the first step here. We are going to have leading and trailing. That is the first step. Right. In the first step, we are going to see all the rules which is applicable for leading first. Okay, right. Now the rule number 1 is any non-terminal term in the left hand side, if it is pointing a first terminal term, so A is a non-terminal and small a is a terminal. So if you find any matching like this in the given grammar, then you need to rewrite this rule as leading of capital A is equal to small a. This is rule number 1, right? Rule number 2, if you are finding any matching like this in a given grammar, A tends to capital X, small a, capital Y. That means a non-terminal and then a terminal and then a non-terminal. Say for example, capital A plus B. F tends to. If you are finding anything like this, then leading of F is equal to plus. Like this, I am going to take like over here. So leading of capital A is equal to the center terminal term small a. So this is how the rule number 2 performs. Rule number 3. A tends to capital B A. If you are finding any of this particular matching in a given grammar, then you need to write it. A is pointing, that is the left hand side non-terminal pointing a right hand side first non-terminal term, that is leading of A is equal to leading of B. So these are all the rules we have in leading. So let me tell you how this trailing works. In the similar manner, quite opposite to it. That is, trailing is quite opposite to leading. You can find here any grammar if it is finding in this particular way, if it is matching in this particular way, like A tends to YA, that is capital, that is non-terminal in the left hand side pointing a last terminal term in the right hand side. Trailing of A is equal to small a. This is rule number 1 in trailing. Rule number 2 in trailing, this rule is common between trailing and leading, that is non-terminal in the left hand side pointing a center terminal term in the right hand side. Non-terminal in the left pointing a center terminal term in the right hand side. That is trailing of capital A is equal to small a. This is rule number 2. Rule number 3 in trailing, that is it is quite opposite to this particular leading, that is leading of, that is capital A, that is a non-terminal in the left hand side points a non-terminal in the right hand side, that is the last non-terminal. In leading we found that is the first non-terminal, but in trailing it is last. So trailing of capital A is equal to trailing of B. So these are the 2 rules for step number 1 to be performed in operator precedence. So this is the given grammar. Example. We are going to take an example and apply this particular rules and find how operator precedence, this grammar is said to be operator precedence or not. Right. So we need to check 2 things, that is there should not be any epsilon in the right hand side, there should not be any two non-terminal adjacent. So you can find nothing is there. So this is said to be an operator precedence grammar. Then we can able to perform. Now this is a grammar is given. This is an input string. Asterisk id is equal to id, right? So with this we are going to apply rule number 1 in leading. That is the first step. So this is a first step. You can see that rule number 1 in leading. So we need to take any given grammar that is applicable for this leading. So in this given grammar, I found this particular production, that is L tends to asterisk or a left hand side non-terminal points a right hand side terminal term, right? So this is exactly matching. This is rule number 1. We are performing only leading, not trailing, right? So here rule number 1 is applied. We found asterisk is the answer, right? The second thing, second matching here, any left hand side non-terminal points a right hand side terminal, the first terminal. id is also a terminal term. So leading of L is equal to id. Let's take union for this. That is leading of L is equal to asterisk and id, right? So let me take you to the rule number 2 in leading, right? We'll perform leading first and then trailing second, right? So which particular leading you can able to apply here? Rule number 2 here. The rule number 2 is a left hand side non-terminal should point a center terminal term in the given grammar. So you take this grammar and apply. I found this, right? That is left hand side non-terminal points a center terminal term. Equal to is a terminal term, right? So we are going to perform leading. Leading of capital S is equal to, right? So there is no more second rule is matching with the given grammar. Let me take it to the last particular rule in leading. So here the leading symbol you can check it. That is S tends to BA, first terminal term. Not only this, we can have so many other leading techniques also. Other matching techniques also for rule number 3. So leading of capital A is equal to leading of capital B. Right. What is the second part here? S tends to L is equal to R. This is the second grammar which is matching there for rule number 3. So leading of capital S is equal to leading of capital L. So if we can find one more symbol is matching, one more production rule, that is L tends to, we'll leave it here. This part R tends to L, that is leading of capital R is equal to leading of capital L. Now we are going to consolidate all this and write the final part of it. If you see all the previous rule, that is rule number 3, leading of S is equal to leading of R, that is equal to leading of L. So altogether we have an answer. What is that? Whatever the value you have in S, whatever the value you have in R, that is L, you consolidate all these non-terminal terms and apply that for S. That is leading of S is equal to asterisk and id. So just I'm going to take the consolidated values for all the leading symbol and I'm going to apply it, right? Second consolidation, right? Number 1, leading of R is equal to leading of L. That is anything you have L that is applicable for R. Leading of L is equal to leading of R. The meaning is anything you have in this R that is applicable for L. The final answer you found here it is asterisk comma id. So we have all the answer which was found exactly for leading and trailing. So I have taken all the values and I have consolidated here, right? So let me take it to the next part of it, that is a trailing part. Yes, you can see here the trailing has been performed. The first rule is a left hand side non-terminal should point a last terminal term in the right hand side. So this is the production which is matching. L tends to id. This is the first as well as last. So L is equal to id. That is T. T stands for trailing. Trailing of L is equal to id. This is the first rule which is matching. Now last non-terminal term, this is the only thing we have. So we will move on to rule number 2. Rule number 2. So here you can see that S tends to L is equal to R. This is the production rule which is matching. A left hand side non-terminal term points a center terminal term. That is trailing of S is equal to, right? So now what is the second highest matching here you can find is, this is a trailing symbol. So we need to find a highest match. So we have one more match here. L tends to asterisk R. That means this is the center part here. You can check it. Trailing of L is equal to asterisk. So both this is applicable for rule number 2. The most important thing is here it is looking for a maximum match. That is the only advantage you have in trialing, not in leading, right? Rule number 3 in trialing, it is almost very similar, but it is very quite opposite to leading. Last non-terminal terms it is matching. A left hand side terminal term, non-terminal term points a last non-terminal term in this particular grammar. So this is the grammar, production rule in the grammar is matching. So trailing of S is equal to trailing of R, right? So what is trailing of R? Trailing of R is equal to trailing of S. Both is synchronizing each other. So trailing of S is equal to trailing of R. Both the part has been done. What is the second thing? We are going to see else tends to asterisk R. That means else tends to asterisk R, that is left hand side non-terminal points are last non-terminal in the right hand side. So trailing of L is equal to trailing of R. So finally R tends to L, right? We have a matching grammar here. This is the first and last non-terminal in the right hand side. So we can apply this rule number 3 here. Trailing of R is equal to trailing of L. So we are going to take all these values and we are going to consolidate. By consolidating all these values similarly, we found this. That is, trailing of S is equal to asterisk ID. Trailing of L is equal to ID asterisk. Trailing of R is equal to asterisk comma ID. So the most important part here it is, as we did in leading, we are doing the same part in trailing also. Whichever is matching for S, whichever is matching for R, whichever is matching for L has been consolidated over here. Thank you.